All right, well, I guess I'm going to go ahead and get started. I see I just had somebody join in. Let me find here's the chat. Oh, there it is. All right. Mohammed, I just sent you a copy of the practice test over the chat. So, hello. Okay. So if you have any questions, ask them in chat. I can send that test again. I'm not sure if we're still getting loaded up. All right, so now I'm going to get started. So this is the prep session or review session for Math 136 Unit 2 exam. And we have a practice test, and I'm just going to go through and answer the questions and kind of talk through them. And just shout out or chat me your questions. Yes.
One, I don't know, but one question I do have. For the first one, do we take the white wood, both coordinates? Do we take them in the order it's given, or do we look at the x values?
You want to see something cool? Like, so you're wondering, does order matter, right? So you have this slope formula, right? N equals y2 minus y1 over x2 minus x1, right? Mm-hmm. So I'm going to do a little aside just to address that topic, because this bugged me until, like, because I know I could test this numerically and it made sense, but sometimes just a little bit of a nudge in the right direction makes things make a little bit more sense. Okay, so I'm going to multiply that by a very interesting looking one, right? So multiplying by 1 is always free, right? Like, it doesn't change anything, right? So I can multiply by 1 over and over and over, all kinds of ways. So in this case, I'm going to multiply by a 1 that looks like -1 divided by -1. What's -1 divided by -1? 1, right? So I can do that, right? I'm not changing anything. So what happens when I do that, right? So if I distribute that through the top, I get -y2 plus y1, and then on the bottom, I get -x2 plus x1, right? And then I can rearrange those, right? So I get y1 minus y2 over x1 minus x2. So what does that tell you?
Oh, so it doesn't matter.
It doesn't matter which way.
Okay.
As long as you're consistent, you have them, you line them up right. So it doesn't matter which ones I designate as x1, y1, and x2, y2, as long as I don't mix them up.
Because like my thinking process was, if I'm looking at the graph left to right, doesn't matter if the slope's negative or positive. I would do the one with the -9 versus the -3, but I didn't know.
Oh yeah,
if that makes sense.
Yeah, so I'm just playing it as it lies. So for some people, it helps if you kind of label those. I know I think I used to do that. So on top, I'm going to have 2 minus 8. And raise your hand if you've ever had issues with getting your signs right. Okay, so maybe going an extra step here. Instead of just putting the numbers down, I'm going to write parentheses minus parentheses over parentheses minus parentheses. Okay. And then I have 2 minus 8 over negative 9 minus negative 3. Okay, so that's a 2. Okay, so on top, that would, you know, they were unnecessary, but 2 minus 8 gives me negative 6. And negative 9, oh, minus negative 3, so that's a plus 3, right? Okay, so then I get, just moving over here, I get negative 6 over negative 6, which is 1. So n equals 1. All right. How's everybody feel about that? Did we spend way too long on that question? I don't know.
Pretty confident.
All right. Given the following piecewise function, evaluate f of 2. All right, so you're with this, you're just going to go on a journey into each little domain for each piece. So I'm going to say, okay, 2. Is 2 in here? No. Is 2 in here? Well, almost, but no. So 2's in this part here. So then f of 2 is going to be equal to negative 3 times 2. So I get negative 6. Questions?
So we just look for the piecewise function. We just look for the equation that has that value.
Yeah, you just look for that part of the definition where 2 is included.
Okay.
So now if I said 3, I'm looking at that and something's bugging me. Why is that bugging me? Oh, okay. No, never mind. Sorry.
Yeah.
I've been a little out of it for a few days, I'd say.
But say, for example, if bottom function 2 is less than, and then have an equal to sign x, then you would just say like undefined or like. Yeah,
like just like we were talking about earlier, you can have a piecewise function that has parts that are not defined, like, you know, you have something that goes from here to here, and then we just skip to there. Then it's undefined from, you know, the x value for this point all the way down to negative infinity. Then there's a huge gap, you know, right in the middle where in between those two solid points, it's undefined. And then it's, you know, undefined after that. So, you know, so you can have that. Like they're just giving you stuff that's nice.
Yeah.
But yeah, you can have gaps where it's not defined. So if for instance I had like f of x is equal to x when, you know, x is greater than 0. And then I had, you know, 0 when x is, let's say, less than negative 10. Okay. And then I said, what's f of negative 2? You'd say it's undefined.
Okay.
Is that what you were asking? Mm-hmm. Yeah. So yeah, if there's a gap and it's not, I don't think they're going to give you anything like that, but
yeah,
you know, understanding things is better than not understanding things. Okay, so now they're giving me 2 points, and they want to know, they want me to give them a line that goes through those 2 points. So if you give me 2 points, I can give you a line. So we need the slope first. So we'll put our training wheels on. So we have -8 minus 8 over -3 minus -4. So then I have -8 minus 8, so that's -16. And then -3 minus -4, so that's +4. So then I have -16 over 1. So then that just simplifies to -16. Okay. So that's just the slope. Now I need to use the point slope form. Can I? Oh, that's a little bit better. Point slope form or formula. It just depends on the professor or the textbook if you call it form or formula typically. So which is y minus y1 is equal to m times x minus x1. And then this is another case where you could use either one of those given points. It doesn't matter if I use this point or this point as the numbers I plug in for x1, y1. As long as I'm consistent, don't mix them up. So, and you know, prove it to yourself. You know, check both ways and confirm that it works.
Yeah.
So y minus, let's see, so y1, let's go with 8 equals -16 times x minus -4. Okay, so if I use this 8 here, then I have to use that -4. So then y minus 8 equals -16 times x plus 4. Okay, and then I can just, so they want it in the slope-intercept form. So our target for slope-intercept form, and if I can spell intercept, is that familiar y equals mx plus b, where m is that very same slope, and b is the y value of the y-intercept. So just turn in the crank here. I'm going to distribute the -16 through, so I get -16 times x minus 64. And then I'm just going to add 8 to both sides. So then I get y equals -16x minus 56. All right, any questions on that one? Pretty straightforward. Just so you know, anybody who's taking calculus, you're going to be like you need to know that for calculus. I know it sounds mundane, but yeah, it's very important that you don't forget how to do what I just did, because it's going to come up over and over and over and over again. Okay, it's going to take a break during trig if you're taking trig after this, but if you're going right into brief calc after this, or the Math 201, then you'll.
Okay.
Actually, all of this stuff is relevant for calculus, so you don't get off the hook on anything here. All right, find the local maximum and the local minimum of the function f of x, which is given in the graph below. So what's a local maximum? What's a local minimum? So if you look in a neighborhood, in just a particular neighborhood, if there's a biggest thing in that neighborhood, then there's a maximum. If you look in a particular neighborhood and you find a smallest thing in that neighborhood, then you have a minimum. So if I like make my neighborhood that little place there I marked off, right? Is there a biggest thing and is there a littlest thing? Keep in mind I used a dashed line, right? So which means I have this open circle and this open circle here. So if you say, well, how about the thing on the border, right? Well, like since I didn't include the border, that means I can just incrementally keep approaching that open point. So then how about here? In that neighborhood, is there a smallest thing? Yeah. So there is a smallest thing right there. So then we would say has a local minimum at, let's see, what is that? -2, -1. And depending on how you guys are wording it, I would say that the minimum value, the local min value is y equals -1, and it's located at x equals -2. Because what's the thing that makes it a minimum? It's its y value. Okay. I don't know how they just give you ordered pairs there, but I want to clarify that. All right. So then if you keep drawing neighborhoods all over the place, eventually maybe you find this guy, and then look, there you go. There's a local maximum. So it's super easy to eyeball these, right? So then our local max at 1, 4. All right. Now if they just gave you the function and you weren't graphing that, once you guys got to calculus, you would actually learn how to find those points. Okay, identify the parent function. I'm just holding my hand to my ear now. I'm listening for the name of the parent function.
I didn't study this.
I'll accept 2 answers, 2 possible answers. Like one of them said, oh, they don't even want the name. I'm looking at the key now. They don't even want the name. They just want the form of it.
I didn't study it.
Okay, so so do you see this? Like, so if you look at this, right, and then you kind of zoom in on that, you can see, okay, so what's the overall behavior? Right? What's that? Yeah, quadratic. Thank you. Somebody's brave today. Thank you. It's quadratic, or you could say f of x equals x squared, or you could say it's a square function. Quadratic is Latin for square. Yep. So yeah. There's an answer key on the back of your thing, so you can quality control me if you need to.
So in the test, do you just write out quadratic?
Yeah, if they just say identify the parent function, you could like if you're writing it in, I would assume they would accept either way, or you could write both, you know, if you're paranoid. Because I saw from helping people with the homework, like they had multiple choice questions where you're supposed to identify it, and they just gave you a list of terms. So I was kind of going off of that, and then I looked at the key and it said, you know, f of x equals x squared. So I'm like, well, either way. Yes.
So to find out the parent function, you just expand it, and then when you expand it, you find out what like say it's to the second degree, you know, it's squared. It's a quadratic function, and the parent function would be x squared.
Yep.
Right. But if it was to the power of 3, it would be x cubed.
Yep, it would be cubic or x cubed.
Okay.
Yep. All right. Number 6, what is the equation with slope -6, which goes through the point -9, -6 in slope intercept form? So here's what they did. They just gave me m equals -6, and then they gave me a point, which I'll just call x1, y1, which is -9, -6. Okay? So if I have a point and a slope, I can use the point slope form. To find the equation of the line. So all I have to do now is just plug and chug. Okay. So let's see, it's y plus 6. And then well, let's simplify the inside first there. Okay, so then y plus 6 is equal to -6x, and then -54. And I can subtract 6 from each side. And then I get my final answer. Y equals -6x minus 60. Okay. Any questions on that one? Like I was telling these 3 here earlier, because I'm 3 because I have one guy online. Okay. This finding the equation of a line is going to be important if you end up taking any version of calculus after this. All right. The next part, write a piecewise function that represents the graph below. Ooh, this one could get a little messy, right? So, if we think about point slope form, sometimes that gives us an opportunity to write down the equation of a line really fast. I'm looking at that middle guy though, and I'm like, what the heck's going on with that one? All right. So it's kind of hard to tell from the picture, but like if this extended, it would go all the way to here. So anyhow, we'll get to that in a minute. So if I look at this first piece, right, I have two options on how to think about how to come up with each piece of this function. I can, if I want, take 2 points off of it and just go through that whole process of where I calculate the slope using the slope formula, y2 minus y1 over x2 minus x1. Plug one of those points and the slope into the point slope form, simplify. I could do that, but I'm lazy and I'm going to do it the quickest way and the easiest way, right? What's the intercept here? 2. What's the slope? 1. So my first piece, so I'll just write this as f of x equals, so I had a slope of 1, so x plus 2, and then like if you're being like super formal, you can put a comma after it, and you can write if or when x is, and that was included, less than or equal to 0. Or sometimes you'll see it, I don't know, how were they writing it earlier? Sorry, I'm scrolling up, guys. Oh, they just put a comma and then the, okay. So I don't need to write an if in there. Let me make it look more like their stuff. All right. Okay, the next bit is a little bit hard to read, but I snuck a look, and this is going up through here like this. So if this were to continue on, so can anybody pick out what that slope is? So I'm going up 1, 3, good. So 1/3 x, and then what's my y-intercept?
1.
Plus 1. And then now, so I can get rid of that scaffolding there, so I don't want that to get in the way. So then this is going from, I'll give you the bottom end. So from 0, not included, to what?
2 included.
Yep, 2 included, so I have to do less than or equal to 2. All right. You guys are doing really good. All right, the next piece. What kind of slope are you seeing there?
Negative.
Negative what?
1.
-1, good. So I can put negative x. And then if I kind of just let this go, where am I hitting? -3, good. And then, so we're going to be starting at 2. And then just going on forever. So they wrote, so if I have that, I can just flip it backwards. So when x is greater than 2. If I want. It's like sometimes you might see people write something like that. But not today. And hey, guess what? We're done. Now, if you're in the test and you're like, oh man, I am not able to think as nimbly as I did the other day when I helped Jeremy put that together in the review session, you can always just pick 2 points. If you can read 2 points off of the function and it's a linear function, you can figure out what it is from there. That's the long way around. You guys saw how fast it was just eyeballing the slope and eyeballing the y-intercept and then just plugging into the slope-intercept form. That's super fast. Okay. All right, describe the transformations needed to obtain the graph of f of x minus 2 minus 4 from the parent function, f of x. So what's that -2 inside do? Which way? Left or right? I'll give you a hint. Left or right?
Oh, isn't it opposite?
Yep.
Right.
Right. Shift right by 2. What's that guy do? That's the one that makes sense. Yep. So shift down by 4. Okay. So, and I'll just leave it there. That's, I think, basically what they have. So, questions? Easy? Oh, wow. Okay, which of the functions are odd functions? Okay, guys. I'm going to talk about even and odd functions for a minute. I don't know why I get so excited about them. All right. So, given function f, so first it has to be a function. It's odd is the same thing as if f of -x is equal to -f of x. And or if you're looking at a picture of it, the graph has origin symmetry. So in other words, like origin symmetry is if you fold the thing in half twice, it overlaps itself. So those are two examples of what origin symmetry looks like. Okay. And then it's even if f of -x is equal to f of x. Or your graph has y-axis symmetry. So if you fold it along the y-axis. And it overlaps itself, okay? So for origin symmetry, you fold it, and then you fold it again, and everything overlaps. For y-axis symmetry, you just fold it along the y-axis, and it overlaps. So if you're like, if they give you a picture and you're trying to eyeball it, that's how you think about it. Now, if you're looking at polynomials, I have a shortcut. You guys, who wants to hear the shortcut? Who's excited to hear the shortcut? Just you, okay. All right, because see all the stuff I just showed you guys, you don't even need any of this to do this problem with my shortcut. So here's the shortcut. if you're looking at a polynomial, so this applies to polynomials, if you're looking at a polynomial and the degree of each term is odd, it is an odd function. If you're looking at a polynomial and the degree of each term is even, then it is an even function. If it is a mixture of odd and even degrees on each term, then it's neither. Okay, if it's not even and it's not odd, it's neither. Okay, so which of the following functions are odd functions? So what's the degree on x? All right, and that's the only term. Okay, so what's the degree here?
5,
Next,
3,
next.
1.
Okay, are those odd?
Odd.
They're all odd,
Yeah.
right? So if they're all odd, I'll work one of these out by hand too. Okay, so I have a 3, a 2, a 1, and what's the degree of that 2 on the end?
That's 1.
It's degree 0.
All 0.
So if it's a constant, the degree on that term is 0.
Wait, so then if the degrees are all odd, it means that the function's odd,
Yes.
and then if it's a mixture, it's neither, and if they're all positive, it's positive.
No, that's no, not like positive, negative. Like if you're talking about the degree
Yeah.
being,
if they're all
oh yeah, like if they're all, yeah, that's a polynomial. Yep.
That's
Yeah. Oh yeah. Now, like we kind of get into the weeds a little bit more if we're talking about rational functions, but a lot of times when they're giving you these, they're going to give you just a polynomial anyway. So since this guy is mixing even and odd, then it's neither. Okay, and look here, degree 5, degree 3, degree 1, so that's odd. Degree 2, degree 0, that's even. So they only asked for odd though. So A, B, and D. And then if you wanted to just check these, right? So if I did f of negative x for that first one, right, it's just negative x, which is just equal to negative f of x. Okay, if I do the next one, f of negative x is 6 times negative x to the 5th minus 3 times negative x cubed plus 2 times negative x. So the first step here is I simplify this, so I get negative 6x to the 5th plus 3x cubed minus 2x. And I stare at that for a minute after simplifying, and I ask myself, did I get the original function back? If I did, then it's an even function. If I did not, the next thing that I should do is factor off a negative. So then I factor off the negative since it's not identical to the original, and I get negative quantity of 6x to the 5th minus 3x cubed plus 2x. So what was my original? 6x to the 5th minus 3x cubed plus 2x. So then I have negative f of x. So you can see these are like little mini proofs. So all you have to do is sub in negative x and you just work it out. And after the first simplification, if it's not even, you factor off a negative sign to check for oddness. If you don't get oddness after that, then you just declare it neither. And I'll leave it at that because I don't know what else I have on here. The next one might be show that something's an even function or whatever. Oh, maybe not. But yeah, question.
Can you go back up to E? Why is it even?
Why is E even?
Yeah. What you said.
Oh, I'll show you. So that's f of x equals 2x squared minus 1. So if I do f of negative x, I get 2 times negative x squared plus 1, or I'm sorry, minus 1. Okay, so then what's negative x quantity squared? Well, that's just x squared, so I get 2x squared minus 1, but that's just the original function. So you can see that that gives me f of negative x is equal to f of x, which is the definition of an even function. All right, good questions. Describe the transformation needed to obtain the graph of y equal to 1/3 of x from the parent function f of x. So what's that gonna do?
I think because you're taking a third of the input, you can scan it, right?
Yeah.
But I don't understand what that's called.
Well, okay, so like here, like if something's like super abstract like this, what's a good thing to do to help you think about it better? Yeah, just come up, make up an example.
Wider,
Let's see if it's.
run frame, as opposed to run.
Let's just make one up. I'm going to do it. All right. Well, let's see. What should I make up? All right. How about let's say we have y equals. Oh, where'd my y go? Or I guess I need to call this f of x equals. Let's go with 9x squared. So then what does that look like, right? That's going to be a skinny parabola, right? And then if I do f of 1/3 of x, so I have to plug it into like a set of parentheses like that. So then I have 9, and then what's 1/3 squared? Well, that's just going to be 1/9. I get x squared. So what does that look like? That's going to be a wider parabola. So it's a, let's see what we want to say, horizontal stretch, right?
I just figured it would be wider because, I mean,
Yeah.
like for the slope, it's like, if it's just x, it's rise 1, run 1. If it's 1/3, it's rise 1, run 3, so it would be,
Great thinking.
that's what I was.
Good. All right, horizontal stretch. If you get stuck, make up an example. It doesn't have to be like super clever and make things cancel out so you don't have to think too hard. But, you know, make up an example, plot, you know, make a table if you need to. Hopefully you're doing this before you take the test to think about these things and not during the test, because, you know, making up an example during the test will take away time from your test. So if there is something that you dread, make sure you're sitting there dreading it and trying to work through it before you take the test, because it's not going to just magically start working during the test. It'll just get worse. Unless you're like somebody who doesn't learn anything until you take the test, which, you know, that's, might as well put a unicorn horn on and all that good stuff. All right. Any questions before moving along? But I was working with a student earlier, and I explained exactly like in a very similar way to the way that you're thinking about it. So that's a good way to think about it. But when presented with something really abstract and you're trying to get it, make up something concrete and look at it. Okay. Graph the equation, 3x minus 3. So put our y-intercept there at -3. Our slope is 3, so I'm going to count up. 1, 2, 3, and then 1 to the right, and then mark another point. Some people like to put in an extra point for good measure, if you want. And I don't know if I have let's see, shape tools. I'm cheating. All right. All right, I'm going to stop cheating now. All right, sorry guys. You don't get shape tools on the test. All right, here we go. I'll do my best. All right, pretend that's a straight line, guys. If you want, you can make up a table for these. I'm not sure if your instructors want to see that anyhow, so you can certainly do that. So. Oh yeah, definitely missed the mark on that one. All right. And then you could go through and plot those points if you want. Let's see, if I would have done that, I would have had a better looking picture. No, it took away my whole line. Okay. Given the following functions, find and simplify f plus g of -2. So if I see f plus g of -2, that's just a fancier way of writing f of -2 plus g of -2. Okay. So then f of -2 is going to be -2 times -2 squared plus 1. And then g of -2, I'm going to have plus 3 times -2 minus 4. And now this has just turned into an order of operations problem. Now, if you type this into a calculator exactly how it's written, your calculator will get the order of operations correct on this. So here I'm going to get -8 plus 1 minus 6. So I'm just doing all my exponentiations, then I do my multiplications, and now I'm going to do my adding and subtracting. So I have, let's see, -7 minus 6, so -13, and then I get -17. You're given the function c of t equals 4t minus 3. I think this is a case where they're just throwing something in that's not x to see how you react to it. So if I do c of -2, I'm just going to replace every place I see a t with -2. I get -8 minus 3, so I get -11. Okay. Any questions on these past two? Pretty straightforward. Okay. Describe the transformation needed to obtain the graph f of negative x from the parent function y equals f of x. I'll give you a hint.
The y-axis? Or
They're just like,
the x-axis? Because if it's.
You were right the first time.
Oh, okay.
It's okay. No, it's okay. All right. Questions? Okay. Now, if it's if you have the negative out in front, it's about the x-axis. So in other words, if it's y equals negative f of x, then that's going to be x-axis. All right. Given the graph of the function f of x shown below, find the average rate of change of the function f of x on the interval 1 to 5. So when they say on the interval 1 to 5, that's an x interval. Okay. So they want to know from here to here. Okay. And it just so happens we have a point there of 125 and a point here of 5. Okay. And the rate of change, or the average rate of change, I should say, between those 2 points is just the slope. So I'm just using that good old m equals y2 minus y1 over x2 minus x1. And I have my given points. So I can do 25. Let me go in order so I don't throw anybody off. So I have 5 minus 25 over 5 minus 1. So I get negative 20 over 4. So I get negative 5. Another way you might see that written is like, you know, average rate of change is f of x2 minus f of x1 over x2 minus x1. I don't know, like if your text or your professor gave you something like that. But you can see, again, that's just the slope formula. But yeah, all the stuff we talked about so far is a lot of topics that you'll hit that first half of the semester in a calculus course, especially this next one. Find the difference quotient, f of x plus h minus f of x all over h for the given function below. So there's one strategy if you want where you can compute the f of x plus h first, but I'll just I have room, I'll do it all in one go. Okay, so then f of x plus h, so all I do is I write down f of x and replace every x I see with an x plus h in parentheses. Okay, minus the original function. So I might have to put parentheses around that. Well, if it's got more than one term, I have to put parentheses around it. Let me clarify that. And now I'm just going to start distributing and simplifying. So I get negative 4x minus 4h plus 1 plus 4x minus 1. And that's all over h. And you can see that these cancel and these cancel. So then I have negative 4h over h, and then the h's, I'll let blue be my cancellation color. The h's cancel, and then I end up with negative 4. Okay, any questions on that before I move on? And the difference quotient is an important thing. Okay. Each answer choice below represents a relation by a set of ordered pairs in which of the answer choices is the relation a function. So what you, like the quick way to go through this and think about it is go through and see if you see any repeats of x values. So 1, nope, negative 3, yep. So look at these. Do the y values match?
No.
No.
It's not.
So not a function. All right, so let's see, negative 1, nope. 8, nope. 6, nope. Okay, so that is a function. So it says in which of the answer choices. Okay, so you got to check all of them. There's not just one. So then let's see, negative 2. Oop, I got a hit. All right, so I look at that and I look at that and I say, oh, nope, not a function. Because what's happening there is it's failing the vertical line test. So if you had a vertical line there, it'd be going through 2 points. Okay, 8, it's only 8, only negative 1, only 5, only negative 2, all right. That is a function. And then, all right, right from the beginning, 7, 1, and 7, 7, that fails the vertical line test, so that's not a function. So my answers are B and D. Find the x and y intercept of the following line and write as an ordered pair. Okay, so to get the x, or to get the y-intercept, you just plug in 0 for x and you get 5 for y. So my y-intercept is just 0, 5. And then to get the x-intercept, you plug in 0 for y, and then solve for x. So what do I get? So subtract 5 from each side, multiply each side by 2, and I get negative 10. So my x-intercept is negative 10, 0. use the graph of the function to find its domain and range in interval notation. So when I think about domain, I think about I shine a light from above everywhere and from below, and I have, where does my kind of my shadow accumulate, right? So I have this, I'm like, okay, so what does that arrow mean? Does that mean it's just, I'm going to assume they mean it's just doing this. So that's just going that way forever. I'll look at the cheat key here. Yeah, all right. Okay, so now if I'm thinking about the range, I do the same thing I just did for the domain. I imagine I'm shining a light from either side, and I'm looking to see where all those shadows add up. So I can see here, that's included, and then going down, and since that function extends in that downward direction, this is just going to keep going down. Okay, and now just writing that out. So for my domain in interval notation, I have -6 not included to positive infinity. For my range, I have negative infinity up to 5, and that is included. Yes?
This confused me because I know that 5 should be included, but when I look at the answer key, it's not.
It's not?
Because logically, I think it should be included, right?
That might just be a typo.
I find like under Newton Alta or whatever, when we do our assignments, it's kind of inconsistent too, kind of.
Well, yeah, I'll just ask Debbie or Eric. I'm not sure who made it, but you know,
Okay.
they're humans, and like me, they probably don't get enough sleep. So
yeah,
you can give them a -1 for making an inequality symbol error or a bracket error. But I'll you know, there's you know, that's to me touching there. So it looks like there's some point that's got, you know, where the y value hits 5. So then we would definitely include that. So that's just a typo in the answer key, which you know, we'll get that fixed, but it's not going to affect you guys because now you know that's a typo. All right. Does the shining the light and the shadow thing help you think about this? Or did you guys already feel pretty comfortable looking at these? Okay. Okay. Find the absolute maximum and minimum value of the function f of x shown below. Okay. So when they say absolute, they mean it's got to be, like, remember how, like, earlier I was saying, you know, for the local, you just look in a local area and see, right? If you're doing the absolute, you're looking everywhere where the function is defined, okay? So is there an absolute biggest y value?
11/2 and 7. Right.
All right, good. So either 11/2, 7 is our, or you could say 5.5 is our absolute max. Okay, is there a smallest value smaller than every other y value on the function? Where's that happen, if it does happen?
3/2 one. Or one, yeah, 3/2.
Yep. So you could have also said 5.5, 7, or here you could have also said 1.5, 1. And that's our absolute. And then, so it's got to be smaller than everything else, and the absolute max has to be bigger than everything else. Okay. Determine the intervals for which the function shown below is increasing, decreasing, and constant. Well, I'm looking at it and it's not constant anywhere. So for it to be constant, you need a horizontal part. And I don't see any of that. So if it's increasing, that means if I pick a point here and I increase x, the next y value is bigger. So you can see here it's increasing up till there. Okay, and then you can see the next place where that starts happening is here. So it starts increasing and increasing until it gets to here. So it's increasing from -infinity up to -3, comma, and then from 1 to 4. You will never use square brackets with these increasing, decreasing, constant intervals. Okay, and then it's decreasing along here till we get to there, and then it's decreasing along here. Okay, and then at these points where I have the open circles, it's not increasing and it's not decreasing there. And you can see what kind of points are those? Those are local mins and maxes, aren't they? All right, so we're decreasing from -3 to 1, and then from 4 to infinity. Okay, which of the following graphs shown below shows a function? Well, if you're looking at these and you're trying to eyeball whether it's a function or not, you can imagine doing a vertical line test, or you could do a vertical line test, and you can see this one passes. Vertical line test, vertical line test. Okay, if it fails the vertical line test once, that's not a function. Okay, vertical line test. Passing everywhere, that's a function. Vertical line test. All right, that's failing, so that is not a function. So A and C. Graph the equation below using transformations. Show and describe each transformation in the order they were applied. All right, guys, there are multiple ways to do this, and I don't know which order your professors told you to do it in, but I will do it in a correct order. So the original function, so my parent function is y equals the absolute value of x box looks like that. Okay. All right. And then what I would suggest doing first is, let's see, I don't know. Do I want to just kind of go through each one, I guess? I'll do the reflection first. So when I reflect, so that's what I mentioned earlier. If you have a negative out front, it flips it or reflects it across the x-axis. What's in my way? There we go. Okay. Oh, wow. Awesome. Okay. Better switch colors. Okay, the next one. So -3. That is just going to take each point, each y value, and multiply it by 3. So if it was at 1, then it's at, or -1, then it's going to be at -3. If it was at -2, it's going to be at -6. If it was at -3, it's going to be at -9. And then similarly, on the other side. Okay. And then how much trouble would I be in if I did the shifts at the same time? Or should I do that? I'll do them separately. Okay, so y equals -3 times x minus 1, and that's going to be a shift to the right by 1. So I'm going to just be shifting each point to the right by 1. Okay,
Shift on the right.
you got it. Let's see. Wish I had more colors. Can I get more colors? Oh, purple. Y equals -3x minus 1 minus 3. So now I'm going to be moving, like she said, each one of those points down by 3. All right, so I'll kind of bolden up the last one there. All right. Make sense? Let's see. Is that all they wanted? Show and describe. All right. If they want words, I guess reflect across x-axis, vertical stretch by factor of 3, shift right by 1, shift down by 3. All right, everybody happy? (24) Describe the transformation needed to obtain the graph of y equals f of 2x plus 4 all minus 3 from the parent function y equals f of x. I feel like we're experts at this by now, right? But okay, if they give you something complicated inside of the functional part, like that, what you need to do first is factor that leading term off of the x and off of everything else inside so that you get something like f of 2 times the quantity of x plus 2, all minus 3. Okay. So then if, so let's see, if what we did earlier was a horizontal, was a stretch, and that was with a fraction, right? So now we're multiplying it by a number that's bigger than 1. So that's going to be a horizontal You can cheat and look at the answer key if you want. No.
Is it horizontal?
Yeah, well, yeah, it's the horizontal what? Compression. Good. So we have a horizontal compression. And I think they say, so you have to take the reciprocal of it, right? By a factor of 1/2. And then, so if we have x plus 2, and this is why factoring is important, because if you try shifting to the left by 4, you will be wrong. So you need to make sure that you factor the inside like that. So then you see that you're shifting left by, oops, I should probably say which way. Left by 2, shift down by 3. Okay. If you do them in that order, nothing bad will happen. Sometimes when you're reflecting, you can get yourself into a little trouble. So be careful. In this case, there were no reflections, so no worries. All right, find the domain restriction on the domain of the following function. Okay, so I'm going to look at the top part first. So is that guy on top going to do anything bad, like divide by 0 or take the square root of a negative? No. Okay, now we look at the bottom. That thing on the bottom can do some bad stuff, right? So what do we not want to happen if something's in the denominator? Can't be 0. So we can't have 2x minus 6 equal to 0. We don't want that to happen, right? And then if it's inside of a square root, right, we can't do what? We can't have 2x minus 6. We don't want that to be less than 0, right? Because that'll be negative. And negative in a square root will give us weird stuff, right? That we're sort of trying to avoid in this class, but you might talk about it every once in a while. So we want what's inside of a square root to be greater than or equal to 0. But if what's inside of it is equal to 0, right, then that's going to make the denominator 0. So we can't quite have that. So what we want to do is say we want 2x minus 6 to just be greater than 0. We're not including the or equal to in this case because it is in the denominator. And then we just solve the inequality. So then we say, all right, add 6 to both sides. Divide both sides by 2. And we're just dividing by a positive. If you divide an inequality by a positive, nothing bad happens. So then I get x is greater than 3. So then if we're writing this in interval notation, then we would say that the domain is 3 to infinity. So if we were doing it in set builder notation, we would say x such that x is greater than 3. I'm not sure which one they want. Okay, they wanted this one. Okay. And that's that. Wow. That's pretty quick, right? This thing goes until 4, right? Well, they gave me a short practice test, which makes me wonder if this is a model of the actual test. Not, it's probably not going to be 1-to-1, but I doubt it's 1-to-1, but usually they give me a ton more problems. And I'm fighting to meet the time. Does anybody want to see any weird examples?
I'm hungry.
You what's that?
I'm hungry.
You're hungry? That's okay. You guys can get going. Thank you for coming, everyone. And oh, I'm sorry, Mohammed. Okay, so do you want to see number 7? Mohammed? You want me to scroll up? Hi. I actually just covered all the problems, and now I'm opening the floor to questions. No, go head up. What problem number am I going to? Like numbers?
I'm pretty sure that's how you're doing some right now.
Like,
Oh.
down? Can you type in what problem number you want me to look at? Thanks, guys. Oh, did I get your name on the sign-in sheet?
Yeah.
Okay, thank you so much. Here, I'm just gonna, since it's just you now, I'm gonna see if I can unmute you. Can you?
Yeah. Hi, hello, teacher. I gone down in some in question I didn't understand. Gonna scroll down.
Scroll down. Okay.
No, it's this one. Number 21.
This one?
Yeah.
Oh, okay.
Mm-hmm.
Did you just want to see it, or do you have a question on it?
I want to understand it's not decreasing.
Let me see if I can turn up the volume. Oh, you want to understand the decreasing?
Yeah.
Okay,
Green one, yeah.
So X going from left to right is increasing, right? So if we say that a function is decreasing, what we mean is as the X value increases, the Y value decreases. So if you look at this point here,
Mm-hmm.
right? When we move up a little bit, right, the Y value goes down.
Mm-hmm.
And then as we move this way, the Y value keeps going down. Then we say that that's decreasing. So it's decreasing. The Y value keeps getting lower as X gets bigger until we get to here, and it's longer here. And then as we move along, we see that it starts increasing.
Let me know here. Is that it decreasing here? Mean I choose X value only?
No, yeah. So you specify
here decreasing here -3 and 1.
I'm sorry.
You say decreasing here -3 and 1.
Yeah. So that's you give the X interval of where the function is decreasing.
Oh, X only, no Y.
Yeah. Because what I'm interested is what's the interval of X values where it's decreasing.
Oh.
So from here to here, right?
Yeah.
And then from here to infinity, it's decreasing.
Mm-hmm.
And then from here to negative infinity, it's increasing, right? So from negative infinity up to -3,
Mm-hmm.
you can see the function is increasing. And then from 1 to 4, you can see the function is increasing. And those are X intervals that you're specifying. So it's whenever they ask, where is it in regard to a function, they want to know the X value. That's how you specify location.
Not Y value, X value only.
Yeah. It's the Y value that determines whether it's increasing or decreasing, and you say where it is using X values.
Oh, okay.
Okay?
Thank you.
You're welcome. Any other questions?
Yeah, that's one.
Just that? All right. Well, hey, thank you for being my online.
Thank you so much, and have a good
Sorry,
weekend. Okay.
Oh, you're welcome.
So, yeah.
All right. Well, I'm gonna shut it down.
Uh-huh.
Thank you for coming.
Thank you.